Interval notation, number line, graphing inequalities, and set builder form. So always make sure your numbers are in the order, means getting bigger on the right hand side or smaller, going smaller to larger as we go towards right. First example is graph the given inequality. X lies between -1 and 3. We can see here x cannot equal -1 and x cannot equal 3. So that means I would be using either open parentheses or open dots, and x can be any value bigger than -1, any value smaller than 3 are allowed values for x. We could go ahead and use the open dots as well to make this graph instead of open parentheses. To write it in the interval notation, we would go ahead and say x lies between -1 and 3. Both -1 and 3 get open parentheses. Also, this is a bounded interval because it's lying between a fixed region, bounded interval. Another example, we want to graph x lying between -6, x less than equals -6, and x less than equals 2. So in this case, I do have an equal sign both ways. So I will be using closed parentheses or closed dot. X can lie between -6 and 2, and x is allowed to equal to -6 and 2 as well. X can be any numbers between -6 and 2, including -6 and 2. To write it in the interval notation, in this case, we would be using bracket around -6 and a bracket around 2 as well. And this is a bounded interval again. Another example, we want to graph x 0 less than x less than equals 4. We can see there is only equal sign on the 4 side, but not on the 0 side. So x lies between 0 and 4. X can equal 4, x cannot equal 0. So 0 gets an open parentheses and 4 gets a closed parentheses, and we can shade in between. We could use the open dot and closed dot as well to represent it. Again, it's a bounded interval. To write in the interval notation, 0 gets open parentheses, 4 gets closed bracket. Another example, number 4, x greater than -2. So x is allowed to be any value greater than -2. That means any value of x bigger than -2 is going to make this inequality true. All the values bigger than -2 lie on the right hand side, and there's no equal sign, so we are using the open parentheses or open dot. And it's an unbounded interval. It doesn't stop anywhere. It's going in an infinite region. So all the values all the way through positive infinity are going to make this inequality true. That means I will be using open parentheses for -2 to infinity. The interval notation would be -2 to infinity, and -2 gets a parentheses. Infinity always gets a parentheses because it does not really exist. It's just a really, really large number that we don't know what it is. So infinity never gets a bracket, always gets a parentheses. Next example, this is number 5 example. Graph x less than equals 4.5. So we're going to find 4.5, and x can be any value less than or equal to 4.5. That means closed bracket, or we could use closed dot. So all the values to the left of 4.5, including 4.5, will make this inequality true. To write it in the interval notation, you want to start with writing far most value on the left hand side. When we write interval notation, we must go from left to right. So -infinity to positive 4.5, -infinity to 4.5. 4.5 gets a bracket, and infinity gets a parentheses. Infinity gets a parentheses, 4.5 gets a bracket. So all the values from -infinity to positive 4.5, including 4.5, will make this inequality true. Next, we want to write these inequalities in the set builder notation, and we also want to graph them. So if I were to write it in the set builder notation, I would say x such that x lies between -2 and 5. X such that x lies between -2 and 5. And interval notation is -2 to 5. If I were to graph it, I would be looking for -2 and 5, shading the region in between. Okay, shading the region in between -2 to 5. Right, another example. Order and interval notation, converting between intervals and inequalities. So I'm given this interval notation from -2 to infinity. I want to write it as an inequality in the set builder notation. So I can say x such that x can be any values between -2 to infinity means any value greater than -2 is an allowed value greater than or equal to -2. What tells me equal to? The closed bracket here. And if we were to graph it, I'm going to be looking for -2 on the number line, and any values to the right of -2 are going to be the allowed values. They will make this inequality true. Another example, we want to write -infinity to 6 as an inequality in the set builder form. So it would be x such that, in this case, all the numbers to the left of 6 are allowed. X such that x is less than 6 would be the set builder form here. And it's unbounded interval. We can see it goes on forever. On the left hand side, it's never ending. And to graph this inequality, we would go ahead and to graph it, we would be able to find the 6 and open parentheses here. All the values to the left of 6 are going to be allowed values. Okay, that's all for, maybe I shouldn't draw the arrow there. That's all for this interval notation and set builder form and graphing inequalities.